Welcome to Rules for Differentiation, finding the derivative of a product of two functions. Rewrite the function f of x equals 2x minus 3 times x squared minus 2x plus 1 as a cubic function. Then find f prime of x. So the only way we know right now to find the derivative of a product is to simplify that so it's no longer a product. So we need to multiply 2x minus 3 times x squared minus 2x plus 1. All right, so we have f of x equals, we got to distribute the 2x to the whole trinomial there, the second factor, so x squared minus 2x plus 1. And then we got to distribute the negative 3 to the x squared minus 2x plus 1. Right, so we have f of x equals 2x times x squared is going to be 2x cubed. 2x times negative 2x is a negative 4x squared. 2x times 1 is 2x. And then negative 3 times x squared is a negative 3x squared. Negative 3 times negative 2x is a positive 6x. Negative 3 times 1 is a negative 3. All right, so now we need to combine our like terms. F of x equals, so we only got one cube. We got two squares, so negative 4x squared and a negative 3x squared is a negative 7x squared. 2x plus 6x is 8x, and then minus 3. So now, after all that, we can take the derivative. Right, so the derivative of f of x, that would be f prime of x. Oh, and by the way, we're going to take the derivative using the power rule. Right, so because it would take us a while to take this derivative using the limit definition. We can do it, but it'll take a little while. So I think we'll just use the power rule. Right, so the derivative of f of x would be f prime of x equals, and that would be take the derivative of 2x cubed. Right, so we're going to multiply exponent times coefficient. Right, so 2 times 3 is going to give us 6x, and we reduce by 1, so that's 6x squared. 2 times negative 7 would be a negative 14, and reduce the exponent by 1. And then 1 times 8 is just 8. Reduce the exponent by 1, it's x to the 0, and so that's just 1, so that's just going to be an 8. And the derivative of negative 3 is 0. All right, so our derivative is 6x squared minus 14x plus 8. A little reminder that what's our equation of f prime of x represent, right? So f prime of x is the function that allows us to find the slope of the tangent line which is also the instantaneous rate of change for a given x value. That's what our derivative tells us, right? Tells us a rate of change. Two men, Isaac Newton and Gottfried Leibniz, are credited for developing the study of calculus, and they actually did that independently of each other. In 1673, Leibniz published an article in which he derived what we know today as the product rule of differentiation. So let's write this rule together in the box below. I already have it written because, well, my typing is nicer than my handwriting. All right, so the derivative, so we want to take the derivative. If you take the derivative of a product, so UV, that's just representing two factors in our product. Another way we can do this, besides simplifying out and using the power rule, is the product rule. Now I'm going to write product rule right above it. And to use the product rule, you take the first term, the first factor, in this case, in the case of our example here, that would have been 2x minus 3, times the derivative of that second term, plus the second term, in our example here, it's x squared minus 2x plus 1, times the derivative of the first term. Right? So a way you can remember it, I'm going to write it down below, I guess, because I'm going to solve it out on the other page. Maybe I can squeeze it in here, so I'll try. Right? So I'll write really small. Right, so product rule. See, I told you my typing is better than my handwriting. So product rule. Take that's the first. And I'll use an asterisk for times. Times the derivative of the second. Plus the second times the derivative of the first. Or will I squeeze the rest of the sentence there? Of the first. I knew I couldn't squeeze it in. How about over here? There we go. Of the first. Boop. Right? So notice that this is not just the product of two derivatives. Sometimes students remember it as u dv plus v du. Right? So the first times the derivative of the second plus the second times the derivative of the first. Right? We just have to make sure that each term is multiplied by the derivative of the other term. And then we add the two together. But it's easier if you're always consistent. Right? So dv is just the derivative. So whether we write, where am I going to write now? Here we go. So the dv, or, so this is just dv. This is the derivative of v with respect to x. That's just referring to the derivative of v. And then likewise, I guess over here, du, or the derivative of u with respect to x just means the derivative of u. There, we squeeze it all in. You might be able to squeeze it better than I can. To show this rule works, let's apply this rule to the function f of x equals 2x minus 3 times x squared minus 2x plus 1 that we rewrote and differentiated as a polynomial above. And if we get the same answer, right, we know we did it right. And it'll show you that you can use the product rule. I am not going to try to squeeze it in on the bottom there. I'm sure you will have no trouble fitting it in there, and you may have more space on your page. I am going to go to the next page where I wrote it down. All right, so we want to take the derivative. All right, so we're taking the derivative of our function. All right, so I like to do my work off to the side here. All right, so a little reminder on the product rule. All right, so if we have the derivative of a product, right, it's going to be the first times the derivative of the second plus the second times the derivative of the first. All right, so let's write all our players down here. All right, so u, that's 2x minus 3, and v, that's x squared minus 2x plus 1. The derivative of u, I'll just put du. Well, that's pretty easy. We use the power rule here. Derivative of 2x, that's just 2. And the derivative of the constant is 0. So we're done there. The derivative of v, all right, so derivative of x squared, 2 moves in front. All right, so we have 2x. And the derivative of negative 2x, that's just negative 2. All right, so now that we have all our players written down, let's plug it into our power rule. All right, so derivative of f of x, that's f prime of x, is equal to, and actually I'm going to, because I have a feeling, knowing that I write a little large, that I might run out of space. So I'm just going to do that. All right, so f prime of x is equal to the first, 2x minus 3, times the derivative of the second, so that's 2x minus 2, plus the second, x squared minus 2x plus 1, times the derivative of the first, which is just 2. All right, so now we'll just multiply and combine our like terms, right? So remember, Always simplify. Oops. I don't know if you saw that, but that's called I did not plug the computer back in. And now the computer is mad at me. So sorry for that. And I've already redone this lesson, not once, but twice, due to little glitches in technology. Well, one of them was me. I forgot to orient the board. There we go. Now that I've entertained you with my stories of recording, I'm plugged in. All right, let's continue our problem here. Sorry about that. All right, so f prime of x is equal to 2x times 2x is going to be 4x squared. 2x times negative 2 is negative 4x. Negative 3 times 2x, negative 6x. Usually I just add those together in my head, but since I've got other terms to add to them, I may as well just add them all together at the same time. Negative 3 times negative 2 is positive 6, and now we're just distributing a 2. So we'll have a 2x squared, a negative 4x, and a positive 2. And I don't see any multiplication errors. Let's combine. I have no idea why there's a parentheses over here, because that's really not needed. Got carried away making parentheses. All right, so let's just add our like terms. All right, so 4x squared plus 2x squared, that's going to be 6x squared. We got a negative 4x, a negative 6x, and a negative 4x. That's going to be a negative 14x. And we have a 6 plus 2. I knew there were two constants. Let's add those together. We have a plus 8. Did we get the same answer as when we multiplied and then took the derivative? And dun, 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 we got the same answer. All right, so that means A, I did not make any errors when I was doing all that multiplication on this page. And B, you can use the product rule. Right? So that's not a true proof of the product rule. I thought about doing a true proof of the product rule, but I thought, I'll let that stand for our proof that you can see that whether you multiply and then take the derivative, or whether you use the product rule, you're going to get the same answer. Now, students may wonder, why is this rule so important if we could just rewrite as a polynomial and easily differentiate it? And the answer to that question is simple. If it's possible to rewrite as a polynomial, you don't always have to do so. You can do so. I don't like that always do so. Let's cross off always do so. You can, and make that you can. Quite honestly, this took me a little less work, and I had a little less multiplication than this one did, right? I had more terms to keep track of. Here, I had a 2 to distribute. That really wasn't so bad, right? If you can simplify it by multiplying and then do the power rule, you certainly can. But sometimes you cannot multiply it. And you can't simplify it into a polynomial, right? Such as g of x equals x squared times sine x. You can't rewrite that as a polynomial. And so we're going to use the product rule to find the slope of the normal line to the graph of gx equals x squared sine x when x equals pi using the product rule, because we couldn't do it any other way, right? So if it's possible to rewrite as a polynomial, you can. It's your choice. But when you can't rewrite as a polynomial, or you don't want to write it as a polynomial because it's something really, really long to multiply, then use the product rule. All right, so let's use the product rule here. So we have g of x equals x squared sine x. All right, little reminder, I'll probably write it each time. You don't have to write it each time in your notes because you have it on the front page, but we can't see the front page. So each time I'll just write it real quickly. All right, so product rule, if we're taking the derivative of a product, it's the first times the derivative of the second plus the second times the derivative of the first, right? So u is x squared and v is sine x. Right? Derivative of u Derivative of x squared, that's 2x. Do you remember the derivative of sine x? Hopefully you remember that us graphing the slopes. It's cosine x. All right, so now we can just use our product rule. G prime of x equals the first, so x squared times the derivative of the second, cosine x, plus the second, which is sine x, times the derivative of the first, which is 2x. Now, I wanted to write it in the exact format, but that is not really a very good way to write the equation. That's just not in math terms. We don't have the 2x hanging outside next to the x over there. So notice I had to use parentheses because that's kind of confusing with an x and there's a 2x. And the sign only applies to the x. We take the sign of x here. So make sure you simplify it correctly and write it in the way, I mean, there's nothing really, technically wrong with this, but that's really just not how we write an equation, right? The 2x should go first, and now I no longer need the parentheses, and doesn't that look nicer? It really does, right? So feel free when you realize that you're writing 2x times sine x to put the 2x first and then the sine x. And if you don't mind, I'll do that in the rest of these, all right? And that's our answer. All right, so except we're not done. That's the answer for our derivative. We have to finish because we were asked to find the slope of the normal line. So first, we took the derivative. That was step 1. So we use the product rule. And by the way, I think you have a whole page to write this. And my R looks remarkably like a V. Number 2, right, we need to find the slope of the tangent line. And to do that, we just find g prime of pi. And so that's going to be a pi squared times cosine pi plus 2 pi times sine pi. And remember where pi is located, right over here. That's the point -1, 0. Right? And the radius here is 1. So sine uses the y. So sine is going to be 0 over 1. Cosine uses the x. So cosine is going to be -1 over 1, right? Just a little friendly reminder there. All right, so g prime of pi is going to be pi squared. Cosine pi is a -1 plus 2 pi times 0. Of course, that will just be 0. And really, we should simplify that -1 and put it in front of the pi squared. So g prime of pi is negative pi squared. Isn't that a lovely number there? It is a number. All right, so, but we're not done because we weren't asked to find the slope of the tangent line. We were asked to find the slope of the normal line. And just remember that they are perpendicular. Right? And so perpendicular lines, they're reciprocals of one another, and the sign's the opposite. Right? So our slope is not going to be negative anymore, it's going to be positive. And if I make it the reciprocal, the pi squared is in the denominator. And my 1 is blending into my p on slope. There we go. So our slope for the normal line is just 1 over pi squared. Leave it like that. Leave exact answers, right? I really need to learn, by the way, how to write smaller. After a while, I start to run out of space on my page. And then I'm always writing at the bottom of the page. All right, let's try another problem using our awesome power rule, or product rule. All right, so we're going to use the derivative to find, we're going to use the product rule to find the derivative of each of the following functions. So you have these in your notes with lots and lots of space. right? I'll just write it really small somewhere just to remind us that the product rule is the first times the derivative of the second plus the second times the derivative, of the first. And I have a recording box up there which you can't see, and I guess I'm apparently way too close to it because I can't write the rest of my x. There we go. Or the rest of my d. And my x is way over here. All right. And you see, some of these we couldn't simplify out and really make them polynomial. And even if we could, so for instance, h of x, yes, we could distribute cosine x to both of terms there, but we wouldn't be any better off because then we'd have 3x times cosine x, and that product can't be simplified. And actually only, well, 2 of them up here could be simplified, but quite honestly, I think I'd rather just use the product rule. But it's going to be totally up to you, except in this lesson where we're practicing the product rule. All right, so u is 2x squared plus 3x. The derivative is going to be 4x plus 3. And then our second term is x squared minus 3, and so the derivative is 2x. They're just using the power rule. All right, so our derivative, f prime of x, is going to be the first 2x squared plus 3x times the derivative of the second, so times 2x, plus the second, which is x squared minus 3, times the derivative of the first, which is 4x plus 3, and now I'm encroaching on the next box. Hopefully I won't need that space. All right, so now we're just going to distribute and combine our like terms. F prime of x is 4x squared plus 6x, and then we have another 4x cubed, sorry. Yeah, 4x cubed, and then a 3x squared, and a negative 12x, and a negative 9. All right, there's no multiplications there. Yep. Yeah, that's good. All right, and we'll combine the like terms, and then we're done. We've got only one cube. 4x squared plus 3x squared is 7x squared. 6x minus 12x is a negative 6x minus 9, and there we go. There's our derivative. I'm going to work my way down. All right, so u is the x cubed. I think I can move down a little bit. Derivative of that is 3x squared. And then our second term is sine x. And if you remember, oops, that was supposed to have a v. And if you remember from the other page, the derivative of sine x is cosine x. Right, so our derivative is going to be the first, the x cubed, times the derivative of the second, so up times cosine x, plus the second sine x times the derivative of the first. Let's just put the 3x squared first, right? He's got to go first, and then the sine x, right? Rather than writing sine x times 3x squared. And really, I didn't need to put the parentheses in, so I'm going to drop them. I don't know why I put them in there. F prime of x equals x cubed. They're not really wrong, but I just don't really need them. So x cubed times cosine x plus 3x squared times sine x. Right? And it's perfectly good to leave it like that. Don't feel like you have to pull out any common factors. Only if we were solving for when the slope of the tangent line was 0. But otherwise, that's perfectly fine. It's the way it is. All right, so we're on to our next one. Remember that square root of x there is x to the 1/2, because we're going to have to change him. All right, so u is x to the 1/2, and v is x squared minus 3x plus 2, and derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2. By the way, I would leave it like that until you were done simplifying, and I'm done with the product rule, and then we could simplify that one out. And then the derivative of x squared minus 3x plus 2 is going to be 2x minus 3. All right? So the derivative g prime of x is going to be the first. So x to the 1/2 times the derivative of the second. Right? So 2x minus 3 plus the second, which is x to the negative 1/2 times the derivative of, got the right terms, I just decided to put them in different order. The second times the derivative of the first. And so this negative exponent is not going to be may or may not be a problem, but it won't be a problem in multiplying, but if we have any terms that are left with a negative exponent, we'll have to simplify them. Right, so g prime of x equals, right, so x to the 1/2 times 2x, that's going to be 2x to the 3/2, right, because you're adding 1/2 plus 2/2, minus 3x to the 1/2, plus, and now we got to distribute, almost forgot about the little x to the negative 1/2 there, x squared times x to the negative 1/2, right, that's going to be x to the, so 4/2 minus 1/2 is 3/2. So that's going to be x to the 3/2, so we can combine some terms there. And then negative 3x times x to the negative 1/2, right? So 2/2 minus 1/2 is 1/2. So this is going to be 3x to the 1/2. This is all we're doing now is multiplying, so it's just a matter of adding and subtracting exponents. 2 times x to the negative 1/2 is just 2 times x to the negative 1/2. All right, we'll combine our like terms and then we'll simplify that negative exponent. G prime of x is equal to, so we've got 3x to the 3/2 and then minus 6x to the 1/2 and plus 2, we may as well move the x to the denominator. Right now, x to the 1/2. You could leave it like that, or g prime of x equals, if you want to put it back as radicals, it would be 3 times the square root of x cubed minus 6 times the square root of x, and then plus 2 divided by the square root of x. Either's fine with me. Sometimes I change it, sometimes I don't. I have a tendency to change it if it's just a square root. Sometimes I don't if it has an exponent on it because, well, my exponents just never look right under a radical. All right, and then the last one there. Let's identify our u's and v's and du's and dv's. All right, so u is 3x plus 2, and v is cosine x. Derivative of u is whopping 3, and the derivative of cosine x is negative sine x. Remember, it's a reflection of sine x. All right, so h prime of x is the first, right, which would be 3x plus 2 times the derivative of the second, which is going to be negative sine x. I'm just going to write it in and then we'll make it look a little bit prettier, like simplifying that negative 1 right there. And then plus, I'm going to have to just kind of go underneath it here. The second times the derivative of the first one. Let's automatically just put the 3 in front there, because that could easily look like cosine x cubed, right, or cosine 3x when it's supposed to be 3 cosine x, and they're not the same. One thing you need to simplify is that negative. It is not minus sine x, it's times a negative sine x. All right, so 2 times a negative 1, that's a negative 2. All right, let's make that look, but we have I'm sorry, but one of us did a very poor job with parentheses. It's 3x plus 2, the first, times the derivative of negative sine x. One of us forgot the parentheses. Right, but it's still 3x times 2 times a negative sine x. Let's simplify that out. H prime of x, and so a lesson for y'all is don't forget the parentheses because you may forget to distribute like I almost did. All right, so 3x times a negative sine x, that's going to be negative 3x sine x. 2 times a negative sine x, that's negative 2 sine x. And then plus 3 cosine x. And no, you cannot combine any of these things because you can't add a negative 3x and a negative 2. Otherwise, you could because they're both the same sign, just a sign x. And there we go. This one's done. So I see from my timer there I'm at 30 minutes. I'm actually almost done with this lesson. But I may break it up into a longer lesson and then a shorter lesson. So we have one, and then we're going to do some things with some tables. Yeah, I think I am going to end this podcast and pick it up in the next podcast. All right, so bye for now.